Hi everyone, welcome to Real Science Challenge. I'm Kent Louie, science teacher and talking head. Talking about science education and broadcasting from beautiful, you know it, Vancouver, Canada. This is episode 112. And today, I want to talk about some recent results from Ontario's standardized tests. Specifically, that 68% of grade 6 students say that they understand most of the math they're taught. But you know what? Only 51% actually meet the provincial standard. That's weird. That's like a 17% gap between people who think they know what's going on and what they actually know. And in a typical classroom of 30 students, this means that about 5 students think they understand math when they actually don't. And these aren't the students who openly struggle, the ones that know they're struggling in math. These are the students who are in the middle. They're quietly slipping through the cracks. And I'm sure this is not happening just in Ontario, but across the country. So I think as science teachers, we can help close this gap by teaching numeracy skills in our classes. And I'm sure many of us are doing so already because numeracy, like understanding numbers, data, trends, and graphing, is already part of our curriculum. So in this episode, I want to share some activities I do at the start of the year with my science classes. And in fact, you can do these activities throughout the year. And these activities teach and highlight numeracy by getting students to practice how to estimate. All right, but before I continue, handouts for this episode are available at realsciencechallenge.com/EP112. And please subscribe to our YouTube channel. Now here's the thing. We always think that science is precise and exact. And you know what, at the highest levels, at the upper levels it can be. But I like to challenge students to think about how people took measurements before we had all the high precision tools we have today. And I'm not talking about just digital devices, but also things like rulers and protractors. Think about how precise those are today compared to like what previous scientists had to deal with. All right, so a lot of scientists had to develop ways to measure time and length and angles accurately and with the things they had at the time. And this is the idea behind what I have students do through my activities. Estimating forces students to think about how they plan to measure something accurately with the simple tools they have. And I don't expect students to be 100% correct. I just need them to explain to me how they're getting their measurements. All right? So for example, with my physics students, I'll put 2 tennis balls at the front of my class at different heights and depths, and then ask students to figure out how far these are. All right, so I'll put one usually right there below my poster on the railing, and I'll put another one right there where the trophy is, if you can see, right at the corner there, and students got to measure that distance. But here's the catch. Students are not allowed to go up there to the wall. They have to stay on this side, in front of that desk, on this side, which works out to be about 6 or 7 feet in front of the wall. And that's where they have to estimate the width, the depth, the height. And they can do this by looking at relative distances, looking at the sizes of the things on my wall, right? Or looking at the things at their desk and trying to compare it to the wall. The point is that through this activity, I'm trying to get students to think of how many things in our world cannot actually be measured directly. We can't just go up to it and measure it with a ruler, like the distance between stars or the size of the nucleus. We need to find ways to estimate their distances, and that's the point of this activity. And this requires us to flex our math skills. Another version of this activity is that I get students to estimate how tall a building is. Looking through the windows of my classroom over there, we can see the other wing of the school. And I get students to estimate the height of that wing by counting bricks, by looking at the windows, by counting the panels, and estimating the size of each brick and window and panel, and then adding it all up. Again, this is an estimation, but it shows that we can estimate the height of something without measuring it directly. Other simple variations of this activity include finding the volume of a irregular shaped object, like a backpack, at the front of the room without going up to it and touching it, all right? Estimating the number of items in a jar like this, full of marbles, and asking students to estimate the total. And maybe they have a strategy, like looking at one section and then counting how many are there and then extrapolating to the next. The point is, they gotta find a method and explain how they got to their measurement. Try these with your classroom. Let me know how they go, and let me know what activities you do with your students. I'm curious because I want to try new stuff as well. All right? Remember, this is all to help students better understand math skills by teaching numeracy across disciplines. That's it for this episode. Please smash the like or subscribe button or leave a comment below. And handouts once again are at realsciencechallenge.com/EP112. Thanks for watching. Let's talk science education again soon.